everybody. Welcome back. Thank you for your patience while we get these videos rolling this crazy week. This is 8.2. We're going to start trigonometric ratios. And to be honest, I think this is the coolest chapter of the whole year. So I hope you have fun with it. Trig ratios involve right triangles and right triangles only. Okay. So before we start learning about trig ratios, we need to learn about the names of the different parts of the triangle. So if we have a right triangle, wherever the right angle is, the side opposite of my right triangle is my hypotenuse always. Okay, so that's my opposite side is my hypotenuse. The side opposite my right angle. And then whatever we're talking about, whatever angle we're dealing with. So if this is my angle, we usually call it sometimes called theta here. So we're always talking about whatever side is relationship to my angle here. And so this is called my opposite side. And this is called my adjacent side. And adjacent means like right next to. Okay. And of course, my hypotenuse is my side opposite my right angle. Okay. So don't confuse that with opposite side from the angle. So whatever angle we are dealing with, my opposite side from the angle, my adjacent side, and then my hypotenuse is my longest side of the triangle. Okay. All right. So now we have those parts. We're going to say, what is the ratio of the opposite side to the hypotenuse in each triangle? Okay. So again, we're always kind of referencing from the angle. And so from this angle here, what is my opposite side? And that's going to be 12. Okay. So my opposite side ratio of my opposite side to my hypotenuse is going to be 12 over my hypotenuse is 13. Okay. And that is the ratio of that opposite side to my hypotenuse. Okay. Let's look over this one. Here's a smaller triangle, but still has an angle of 67.4, right? So what's the ratio of this one, my opposite side again? So we're going to go opposite side again to my hypotenuse. And that is going to be 6 is my opposite side over my hypotenuse, 6.5. Well, we're going to calculate those. We have this 12 divided by 13 here. So 12 divided by 13. We calculate that ratio. It's 0.9321. We're just going to kind of 0.9321. We're going to round to 4 decimal places. So with trigonometry, we usually round to those 4 decimal places. Now I'm going to take the 6 divided by 6.5. And that one is the exact same. Okay. So that's going to be also 0.9321. And so what you'll notice is no matter what, if we end up with these triangles that have these same angles, if this is 90 and that's 67.4, then this is going to be the same angle on this third side, right? So if we have the same angles of a triangle, the ratios of these sides are always going to be the same. And we have special names for those ratios. So let's look at this one here and say, well, what is the ratio of the opposite side to this hypotenuse? Well, here's my angle theta. And so my opposite side is going to be 4. So if I take my opposite side again to my hypotenuse, the ratio is going to be 4 over my hypotenuse of 5. Okay. And then if we take that 4 divided by 5, we end up with about 0.8 is my ratio. Okay. So there's a special name for this ratio and it's called sine. We actually have 3 ratios: sine, cosine, and tangent. They each have different ratios. Since we have 3 different parts to our triangle, we have 3 different ratios. The sine is the ratio of the length of the opposite side divided by the hypotenuse. The cosine, we write that as COS. Sine is SIN. It's not sin and it's not cos. It's called sine and cosine. Okay. And cosine is the length of the adjacent side divided by the hypotenuse. And the tangent is the length of the opposite side divided by the opposite leg. So those are the 2 legs. Okay, so sine and cosine involve dividing by the hypotenuse, and the tangent divides by the legs. Okay, so these you just have to kind of memorize, and these was a little kind of a trick we use to memorize these called SOHCAHTOA. This is sine equals opposite divided by hypotenuse. That's my SO. Ka is cosine equals adjacent divided by hypotenuse. And TOA is tangent equals opposite divided by adjacent. So that's SOHCAHTOA. Okay. And again, here's my right angle. My hypotenuse is opposite my right angle. And then here's my angle, my opposite side, and my adjacent side. Okay. Once you kind of get all those down, then it really is just kind of putting it all together. okay? So it says, what is the sine, cosine, and tangent ratios for angle H? So it's really important that you know which angle am I talking about here, which one are we using? So we're using angle H. So make sure we know we're going from this angle, because it really depends which angle, which is the opposite side, right? And so for angle H, my sine of H equals the opposite from H is 12 divided by my hypotenuse, 15. Okay? And then my cosine of H is going to be my leg adjacent. So it's going to be my 9, that's my leg adjacent to H, divided by my hypotenuse, 15. Okay? Then my tangent is going to be my length of my opposite side, 12, divided by my adjacent side, 9. So it'll be 12 ninths. Now, usually when we're doing these, we want to make sure we reduce these fractions. This is 3 will go into both 12 and 15. So 3 will go into 12 4 times. 3 will go into 15 5 times. The ratio would be 4/5. Same thing here. 3 will go into both of these 3 times, and 3 will go into that 5 times. And same thing here. 3 goes into 12 4 times. 3 goes into 9 3 times. And so when we're doing those ratios, make sure you are also simplifying. Okay, so now let's talk about angle F. We did angle H last time. Now let's do angle F here. Okay, so from angle F, let's look at the sine ratio. So my sine of angle F equals, it's going to be 9 divided by 15, which is going to reduce to 3 goes into both 9 and 15, 3/5. Okay, so that's my sine ratio. Let's look at my cosine ratio. So my cosine of F, not cos, let me say cos, okay, is going to be my adjacent leg, 12, divided by my hypotenuse, 15. And 3 will go into both of those, 4/5. Okay, and now let's look at our tangent. My tangent, not tan, it's pronounced tangent, of F is my opposite leg, 9, divided by my adjacent leg, 12. And 3 will go into both of those, 3/4 there, and so my 3/4 ratio. Okay? And that's how you simplify those guys. All right. So now let's look at the sine and cosine and tangent ratios for my special right triangles and kind of see what they have in common here. So if I have my, my ratios of 1, 1, and square root of 2, my sine of 45 is the same no matter which angle it is, because it's the same angle. So my sine of 45 is going to be opposite 1 over my hypotenuse, square root of 2, which is going to simplify to square root of 2 over 2. Okay. Cosine is going to be the same, right? Because it's the same thing. Adjacent over hypotenuse is going to be the same thing. 1 over square root of 2, which is going to be square root of 2 over 2. My tangent is just going to be 1, because it's just 1 divided by 1. So a lot of times when you have these, when you set up these ratios, you can just, instead of putting them in the calculator, you just know the square root of 2 over 2 or just 1. Okay. How about our 30, 60, 90 triangles? What are those like? So let's look at our 30-degree angle. For our 30-degree angle here, my sine is going to be 1/2. So sine of 30 is always 1/2. Okay. My cosine of 30 is going to be the square root of 3 over 2. And my tangent of 30 is going to be opposite over adjacent. So 1 over square root of 3, which is going to end up being square root of 3 over 3 simplified. Okay. How about my sine of 60 degrees? Let's look at our 60 degrees. Sine is going to be square root of 3 over 2. Okay. Notice that, well, I'll talk about that in a second. So cosine of 60 is going to be my adjacent over hypotenuse, which is 1/2. And my tangent of 60 is going to be square root of 3 over 1. Oh, I have to go back here. My apologies with this guy right here. No, that's right. Sorry. Okay. So when we look at each of these here, notice that my sine of 60 and my cosine of 60 are the same thing, right? My cosine of 30 and my sine of 60 are the same thing. And notice that my tangent aren't the same thing, but they are reciprocals of each other. Okay, and so pay attention to that. And so these are supplementary angles. And so you'll notice because this is 90, these other two angles have to add up to 90 because the triangles add up to 180. So if I take the sine of one angle, it's going to be equal to the cosine of the other angle. Okay, and that is kind of our next kind of discovery here. But first of all, let's use these trig ratios to find the value of x for each triangle. So right here, we want to find the value of x here. So we have a side adjacent and my side x. So we would say, what is the cosine of 45 would equal 6 over x, right? Well, we know that our cosine of 45, if we go back here, my cosine of 45 is square root of 2 over 2, right? So I can substitute that for square root of 2 over 2 equals 6 over x. Well, I can flip those both upside down. Square root of 2, whoops, not square root of 2. I go 2 over square root of 2 equals x over 6. I get my 6 on top there. And I can just multiply 6 on both sides. So I end up with 12 over square root of 2 equals my x. And I can multiply top and bottom by square root of 2 here to just be sure that I rationalize that guy. So 12 square root of 2 over 2. And 2 divides into 12 6 times. So 6 square root of 2 equals my x. Okay. Now, that's a long way to go about doing it because I can just look at this special right triangle and say if my side length is 6, I know that x is going to be just 6 square root of 2, right? And so I just kind of want to show you that relationship for the special right triangles. Okay. Same thing with my special 30, 60, 90 triangles. I know if this hypotenuse here is 12, this is going to be 6, and this is going to be 6 square root of 3. But you can kind of see the relationship between the trigonometric ratios and my special right triangle ratios. Okay, so again, how are the sine and cosine of complementary angles related? Well, we know that the sine of one angle is equal to the cosine of the other angle, right? So right here, if I put the sine of 30 degrees, that one's going to be my opposite over my hypotenuse, so 1 over square root of 3. And I'm not going to simplify that right now, just for argument's sake. So if I take my cosine of 60 degrees, so notice that these are supplementary angles, my cosine is going to be 1 over square root of 3. So notice that those are equal. Okay. Same thing over here. Let's look at this guy. If we take our sine of our 70 degree angle, right? Our sine is going to be A over C. Our cosine of our 20 degree angle, our supplementary angle, is going to be A over C. Okay. And so the sine of one angle equals the cosine of the other angle and vice versa. And remember, our tangents are reciprocals of each other. Okay. So what is the value of z in this guy here? So if this we can just use our special right triangle ratios here. So if my hypotenuse is 24, we know that 24 equals my leg z times the square root of 2. So I just have to divide by square root of 2. And so 24 over square root of 2 equals my z. But of course, I need to rationalize that denominator. So it's 24 square root of 2 over 2. And so therefore, 2 goes into 24 12 times. 12 square root of 2 equals z. Okay? Okay, so this is kind of an introduction to just the ratios themselves. Right now, I want to kind of show you how to use your calculator to find the trig ratios. We used to use just a big table and calculate every single possible angle measure. We're not going to do that anymore. So when you're using your calculator, the first thing you want to do is make sure it is in degree mode. Okay, and every calculator is different. I come into my mode right here, and I have to make sure I go down and get it into degree mode. Okay, if it's not in degree mode, it's going to really mess you up. Okay. So then I'm going to come out of here and I can go over to this and say, what is my sine of 32 degrees? You should see in your calculator this. If you don't have that, you don't have a scientific calculator and you're going to be in big trouble. So make sure you have a scientific calculator. Okay. So I'm going to take sine of 32 degrees. So I'm going to put sine 32. I notice that there's a parenthesis there. So I have to close that parenthesis and put enter. Now you guys might have to put in 32 first and then hit sign. So you might have to play around with your calculator and make sure you get the same thing that I get here. Okay. So this is going to be equal to, whoops, I moved my calculator here. 5.5299. And when we're calculating these trig ratios, we always go to 4 decimal places. Okay. Now, when we're solving problems, we always go to maybe tenths or whatever. So, but when we're actually calculating a trig ratio, it's 4 decimal places. So 0.5299 right here, 0.5299. Okay. So you guys might want to try some of these other ones with me. See if you get your proper one. Okay. So tangent. So now I'm going to go tangent of 52. Close my parenthesis, and I get 1.2799. Okay. 1.2799. Now notice that my tangent's the only one that's going to be over 1. Cosine is going to be the one. Cosine and sine are never going to go over 1. And I wonder why. Okay, let's go cosine of 84. Think about why those are never going to be over 1. Because I'm always dividing by my hypotenuse, which is longer than my other two sides, right? And so it's never going to be bigger than 1. So 0.1045. 0.1045. Okay. And let's try sine of 16. Sine of 16. And that is 0.2756. 0.2756. Okay. And that's how you find your trig ratios. So now let's put that to use. So use trig ratios to find the value of the variable round to the nearest tenth. Okay. So when you're choosing the right trigonometric ratio, you have to look at your angle and find out which sides do you have. So here I have an opposite side and I have a hypotenuse. That ratio involves my sine ratio. Okay. So remember my sine of x equals my opposite over my hypotenuse. I should put my sine of theta actually. Okay, sine of theta. And so I have my angle. So I'm just going to plug in my sine of my angle, 28 degrees, equals my opposite x over my hypotenuse 19. So I just plug in the things I know and leave my variable what I don't know. Okay. Then I will calculate what is the sine of 28 degrees. Well, sine of 28 right here, boom, 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 is 0.4695. So notice right here, that's a 7. So I'm going to round this number up to 5. Okay. So 0.4695. 0.4695 equals x over 19. And now what I need to do is multiply both sides by 19. Okay, and so if I take that guy and multiply both sides by 19, I will end up with about 8.9. Now usually at this point, this is when we're going to round to the nearest tenth. Okay, not with our trig ratio. Okay, we always round our trig ratios to 4 places, but now we're finding our length is going to be approximately, was it 8.9? I can't even remember what I saw. So there we go. Okay, 8.9. Okay, how about this guy? Here we have, look what we have. We have from our angle, we have, oh gosh, I didn't writing here. From our angle here, we have an opposite side and a adjacent side. So that's my tangent ratio. So I'm going to use my tangent this time. So my tangent of my angle of theta equals my opposite side over my 32. Okay, so I have my tangent of 41 degrees equals x over 32. Okay, so now what I need to do is calculate my 41 degrees. So tangent of 41 degrees equals 0.869. And again, here's my 8 here. So I need to round this up to a 3. So 0.8693. 0.8693 equals x over 32. And now I'm going to multiply 32 on each side. Okay, I'll take my calculator here again and multiply by 32 on each side. And that gives us 27.8 about. So x is approximately equal to, and remember, this is where I say that approximations, right? X is approximately equal to 27.8. Okay. When we write them as a ratio, it's exact. When we use a calculator, we get approximations. Okay. Okay, so you might want to try this and then come back and see how you do. All right. All right, so here we have our angle and we have an adjacent side and a hypotenuse. So that's going to be my cosine. So I'm going to take my cosine of my theta is my adjacent side over my hypotenuse. Okay, so cosine of 21 equals my adjacent side x over my hypotenuse 26. So what's my cosine of 21? Cosine of 21 is 0.9336. So 0.9336 equals x over 26. So I'm going to multiply 26 on both sides. Whoops, times 26. Take my calculator, times 26 on both sides. And that's going to give me, whoops, I do not want that one. Times 26 on both sides, it's going to be 24.3. Okay, so again, rounding, we get x is approximately equal to 24.3. Okay, one more. This time I have angle and I have an opposite side and a hypotenuse. So this time I'm going to use my sine again. That's the one that uses my opposite side over my hypotenuse. Yeah, it's the hardest part probably is identifying which ratio to use. Sine of theta, sorry about that. So I have my sine of my angle, 33 degrees, equals my opposite side, whoops, 15, over x, my hypotenuse. So let's find out what my sine of 33 degree is. Sine of 33 is 0.5446. 0.5446 equals 15 over x. And now x is in the denominator now. So how do I get my x in my numerator? Okay, so there's a couple different ways we can do this. I can either flip both sides, or I can just go ahead and just multiply by x. This is the fine way to do it. Not a big deal. So 0.5446x equals, equals 15. And then I'm going to go ahead and divide by that 0.544x. 446, not x, sorry, 0.5446. So I'm going to take my 15, and divide it by that 0.5446. And it's going to get me about 24.5. Okay, so x is going to be about equal to 24.5. Okay, and that is my trigonometry ratios. Now, just a little bit of a trick I can teach you, and I don't want you to rely on this too much because you need to understand the ratios first. But sometimes they have these old trig ratios. Okay, so if you have so, ka, toa like this, okay, and when you set up your equation, whatever letter's missing, if you kind of cover up the sign, if I'm missing the, we'll talk about missing angles later. If I'm missing the opposite side, I know I'm going to multiply the sine and the hypotenuse. If I'm missing the hypotenuse, I know I'm going to take the opposite side and divide by the sine of that angle. Okay, if I have a cosine, same thing. If I'm missing my hypotenuse, I'm going to take my adjacent side and divide by my cosine of my angle. If I'm missing the adjacent side, I'm going to take my cosine of the angle and multiply by the hypotenuse. This is kind of a fun little trick, these little triangles they have. Okay, but you have to remember how to set them up. Okay, so you have an Excel. Make sure you kind of write down your ratios so you can make sure you understand them and memorize those, make them your friends because we're going to use them a lot. Okay, and I will catch you guys in our next either hybrid or Zoom. All right, talk to you later. Bye-bye.